Hi, hello everyone. This is Dr. Chiranjeevi Manike, Professor and Head of Data Science and Cybersecurity Department, MLR Institute of Technology, Hyderabad. As part of data mining video lecture series, in this video, we are going to discuss statistical approaches to detect the outliers. In this, we are going to discuss mainly the parametric and the non-parametric methods. So, as with the statistical methods for clustering statistical methods, for outlier detection makes the assumptions about the data normality. So they assume that the normal objects in a data set are generated by a stochastic process or the generative model. So consequently, normal objects occur in a region of high probability for the stochastic model, and objects in the region of low probabilities would be considered as outliers. So the general idea behind this statistical methods for outlier detection is to learn a generative model fitting the given data set and then identify those objects in the low probability regions of the model as outliers. However, there are many different ways to learn the generative models. In general, the statistical methods for outlier detection can be divided into the two major categories, like parametric methods and non-parametric methods, according to how the models are specified and learned. A parametric method assumes that the normal data objects are generated by a parameter distribution with a parameter. So that means we are making some assumption that the data is following a distribution with a parameter theta. So the probability density function of the parametric distribution of x theta gives the probability that x is generated by the distribution. So the smaller this value, the more likely x is an outlier. Another method is a non-parametric methods, that is, does not assume a prior statistical model. Instead, a non-parametric method tries to determine the model from the input data. There is no basic assumptions like parametric methods. So most non-parametric methods do not assume that the model is completely parameter free. Such as assumptions would make the learning the model from data almost mission impossible. Instead, non-parametric methods often take the position that the number and the nature of the parameters are flexible and are not fixed in advance. For example, non-parametric methods include the histograms, kernel density estimations, etc. So detection, here these parametric methods and non-parametric methods, mainly that is whether the data set is going to have the single variable or multi-variables or like that. So that based on that, the detection would be done. So detection of univariate outliers based on the normal distributions, detection of multivariate outliers, so using both of the combination like parametric distributions. So let us see one by one with the small examples and small example. So detection of univariate outliers based on the normal distributions. So univariate means when we are dealing with a single variable, then that is called as univariate. So the detection of univariate outliers based on the normal distributions. Suppose city's average temperature values in the July in the last 10 years are in value ascending order, like 24, 28, like etc. So let us assume that the average temperature follows a normal distribution, which is determined by the two parameters, mean, mu, and the standard deviation, sigma. So we can use the maximum likelihood method to estimate the parameters. So by using this maximum likelihood estimates, sigma and variance, mu and sigma square, we will find out the values. So once we plug those values into these equations, then we'll get the mean is 28.61 and the variance is 2.21. So we can from this we can calculate the sigma, that is a square root of 2.29, that is equal to 1.51. So that is so that is, and if you go back to the previous example, in this case So that is the smallest value, that is 24.0. So 24 point, and this is if you 24.0, so then that would be equal to 4.61. So then the sigma that we can divide, that is mu minus, that is if you plug these values, x minus mu by sigma, so that means 4.61 is, and then 1.51, this is equal to 03.04, that is greater than 3. So that means the standard deviation, the sigma equal to standard deviation. So when we compare this standard deviation, like a log normal distribution, let me draw it more. This is a normally distributed data, the mu equal to 0, and this is one standard deviation away, and this is 2 standard deviations away, 3 standard, let us say. This may not exactly represent, minus 1 standard deviation, and this is minus 2 standard deviations, minus 3 standard deviations. Okay, so from this what we understand, the standard deviation is more than 3. That means, so here 99.7% of the data is one standard, 99.7% of the data is a one standard deviation away from the, 3 standard deviations away from the mean. But the standard deviation from this example, that is equal to, that is more than 3. So that means that is very less probability, like 0.15% of the probability that belongs to this. So that would be considered as an outlier. And we can also use the maximum likelihood, that is to estimate the parameters. Another like a box plot, that is to find out this univariate analysis, that is detection of the univariates. So this is another box plot representation. Let us quickly understand what are all these values. So this box plot has the minimum, the minimum non-outlier value, and this is a max non-outlier value, and there is a interquartile range, that is Q3 minus Q1 interquartile range, and these are called as a whiskers, and this is a box, and this is a median, and this entire would be divided into the 4 partitions, like each is going to have the 25%, 25 total, 100% of the data. So the data, this means, what does it mean 25% means? So 25% of the data points are within this range Q2 and Q3, and the 25% of the data points Q1 and Q2, like and this 25% from this minimum, that is within this range. So here, to find out the outliers, so we have to, in this, what values, so what values would be considered as outliers by using this box plot. Box plot could be constructed for a univariate, single variable, and this is also called as a 5-value summary. So in this is the max non-outlier value, and this is the minimum non-outlier value, and beyond the max and below the minimum, up to what level we would consider as a non-outliers. So the data, like based on this interquartile range, that is a Q3 plus 1.5 times IQR, and this is one range, and the Q1 minus 1.5 times IQR. This is IQR. So the values within the range, that is 99.3% of the data will be within this range. So, and the data points which are outside this range would be considered as outliers. So this is the way we can find out the outliers by using this univariate analysis using box plots. Another simple statistical method for univariate analysis outlier detection using the normal distribution, that is called as a Grubbs test, and this is also known as a maximum norm residual test. Next, detection of multivariate outliers. So that means more than two variables. So multivariate outlier detections, it could be done using the Mahalanobis distance, and another is a chi-square statistics. So we can also use a mixture of parametric distributions also. That means if you assume that the data were generated by a normal distribution, so this works well in many situations, but this situation may overly simplified when the actual data distribution is a complex. So in such cases, we instead assume that the data were generated by a mixture of parametric distributions. So multivariate outlier detection using the multiple parametric distributions, and another one is a multivariate outlier detection using the multiple clusters. So let us see each one. The multivariate outlier detection using a multiple parametric distributions. Like from this example, you can see like a previous univariate analysis, we detected the outliers based on the single parameter, that is mean or any other. But whereas it is multivariate outlier detection, that is we have to use the multiple parameters. Like suppose here we can use mu1 and mu2. These are the two means. That is, let us say because from this diagram we can easily understand that there are two big clusters, C1 and C2, these two clusters. Suppose if the mean is in between this, between these two clusters, so then the points, the outliers which are near to this point or the mean would not be treated because those are very close to the mean. So that's why we have to use the different parameters, like mu1 and mu2 are the two parameters, means we are going to use to find out the outliers. So that, and for one distribution we follow this mu1, and then for another distribution we follow this mu2, and the rest of the data points which are not following either mu1 or mu2, those data points would be treated as the outliers. So here in this case, in this object O, that is detected as outlier because if it does not belong to any cluster, that is the probability is very low that it was generated by the combination of these two distributions. Next one is multivariate outlier detection using the multiple clusters. So here this is one cluster and this is another cluster, and you can also find out another cluster like a C3 here. So in this we can identify that the objects in the C3 as outliers because it's a very small cluster and the data points are the density is very high. So so now that's why we can detect this or we could identify this as C3, cluster C3 as an outlier, but it is difficult, like because it's to identify the distribution of this particular cluster. So that's why we have to follow this a normal distribution of the mixture of multiple distributions. This is because the probability of objects in the C3 will be higher than some of the noise objects like object O. So due to the higher local density in this C3. In non-parametric methods for outlier detection, the model of normal data is learned from the input data rather than assuming one a priori. So non-parametric methods often make fewer assumptions about the data and thus can be applicable in more scenarios. So one of the best approaches to detect the outliers using this non-parametric method is histograms. Thank you for watching the video.